Ton left in our 2-4, but it's Raptor time day. So we have a short hour again. I mean, my goal was to try and finish this up yesterday so you could have today to work on it, but that didn't happen. And so we will finish up today, and you'll have a lot less time than I wanted to give you, but you'll have some time. So this one says, or at least yesterday, the one we ended with was we had a piece function. We had to figure out if there is any places that were not differentiable. I want to call people that haven't gotten called on for a while here. Sometimes the roller just doesn't do it. Sometimes picking just doesn't do it. Maggie?
Yeah.
Do you remember what differentiable meant? Since that was like half our questions, it's probably important.
Yeah, differential is like the derivative.
Yep. So differentiable just kind of refers to slope. So if something is differentiable, that means it has a slope answer. If it is not differentiable, there is no slope answer there. So this one says, show algebraically, using the alternate form of the derivative, why g of x is not differentiable. Well, that's a lot of words and stuff. Who should we go with? Wait, Elena, I don't know how I didn't think to call on you first. We should make you first every day. Elena, how do I use the alternate form of the derivative? Like, do you remember what that means when it says to use those words?
You plug in one until this one's.
Kind of. So what you were saying is to check if it's continuous.
Yeah.
So if you plug one into both of those, you would get one for both of those answers. And so then that tells us that these two pieces meet each other and it's continuous. But what we're actually trying to figure out is it differentiable? So we have to figure out if they have the same slopes. So the alternate form of the derivative,
Do you find the derivative from one from the left and then one from, so you do the derivative of both the functions?
yes. So I'm never going to force you to use the alternate form of the derivative. I don't care if you do. That's the one, I'll write it out. The alternate form is where you plug in the number you want to find the slope at. And then you would have f of x minus f of 1 over x minus 1. And then this would be the alternate form of the derivative for x squared. And then this would factor and cancel because it's got a hole at x minus 1. And then this would turn into the limit of x plus 1 as x approaches 1. And so it's basically telling us that the slope is 2 on the left. But 100% you could just do the normal derivative and then plug in 1. Okay, so there's the left. Now we need to do the slope on the right. So we would have the limit as x approaches 1 of f of x minus f of 1 over x minus 1. And then that reduces down to 1. And if I plug 1 in, there's nowhere to plug it in, so the answer is 1. So this would be the slope on the right. I suppose if I were being even better notation, I could put 1 minus and 1 plus. But either way, these two slopes are different. So a slope of 2 is not equal to a slope of 1. That means it is not differentiable because the slopes are not the same. That's algebraically how we would do it. Do you guys want me to draw it?
I just have a question, so, like, when it says why is it not differentiable, could you just, like, do G prime of 1, like, from the right is not equal to G prime of 1 from the left? Like, after you did all of that?
Like,
Like,
as,
when it says,
like trying to state the reason?
Yeah.
Sure. Like something like this?
Yeah,
Sure.
like, that's fine, okay.
There's a lot of different ways to say the same thing. I know they're very picky about notation, but a lot of the notation is kind of like replaceable, I guess. Sure, I can draw it up there though too. So x equals 1 is kind of like my border. So I'm gonna have one graph on the left of it and one graph on the right of it. So x squared to the left of 1 and including 1. Well, if I draw a parabola, it would be 1, 1, 2, 4. And this is a filled in circle. And on the right hand side of that, I would have y equals x, which is just a 45-degree angle. It would be an open circle, but directly on top of this filled in circle. And they do not have the exact same slope at that spot, so it's not differentiable. If they both had the same slope, it would be. And you will get some like that. Sorry.
So were you getting like x minus 1 over x minus 1? Were you like, or like x squared minus 1 over that?
So the alternate form of the derivative, so like g prime of a would be the derivative at that number. So we would want to do it 1. Is going to be the limit as x approaches a of f of x minus f of a over x minus a.
Okay.
So the original function goes the first, so on both of those, that's where that came from. The second number came from plugging that number into the original equation. And then these are kind of set up to work out nice. How are we feeling on this one? Is this one you could have done on your own? I guess it's mainly that. You really won't ever have to worry about drawing the piece functions on your own. I mean, maybe you want to help yourself out, but you don't have to. Should I move on? Should I? Okay, the next part is on your calculators. Now that we've done everything by hand, now we finally get to tell you how to figure out the answers in the calculator. And there's 2 different ways to do it. I'm guessing some people have an 83 in here, most likely? No, really? This might be the first year I've had not have a TA83. Okay, so the only reason I asked is because then I would have to show 2 different ways to do this. No, I don't. Okay. We're gonna try to find the slope. It doesn't even matter what equation. We're gonna do x squared minus 5x plus 6 at -3. Does anybody have an Inspire? No? Roger, what's that one?
Yes.
Do you know how to use it already?
Most of the time, yeah.
Okay,
And after-
directions won't be in the packet, but I can usually find it for you too.
Right.
Okay, so there's multiple places to get to the derivative. The hidden menu is the easiest location to find it. So you're gonna hit alpha, and then F2 is the calc stuff. And, n derive, number 3, is to find the derivative. Now, this cannot find you a derivative equation. It can only find you a number derivative. So that's why it's called numeric derivative. So d dx, and then this is where we would type the equation in. I already forgot what it was. It was like x squared. Perfect, thank you. So x squared minus 5x plus 6, and then right there is where you would enter what number you want to find the slope at. I think it was -3. And you just hit enter. And there's not much to it. The hardest part is actually finding the derivative button. Now you don't want to consider these like perfect, can't be wrong. Because the way the calculator figures out a derivative is that it finds the derivative, it plugs in a bunch of numbers really close to each other, and then finds the slope between them. So when you get non-differentiable locations, like a sharp point, it messes them up quite frequently because it just finds 2 points close to each other. And I believe that's what the next page is. So the next page in your notes gives you the 3 examples we've done that were all undifferentiable at a location. Because isn't the next one x minus 1? Yeah. Okay, I'll show you where all the notation is. Let's do the derivative part first, so secret menu F2. Absolute value symbol is also in that exact same spot. If I go back to F2, it's the very first choice. Now, FYI, the secret menu is basically just shortcuts to the same things. Almost every single one of these is under the math button in some location. The F2 is just supposed to be a faster way of getting to it. I think it was x minus 1. And then we know that there's a sharp point at 1, but if we find the slope at 1, it may or may not give us an answer. Yeah. So it just found 2 points really close to each other, and because they are on opposite sides of the sharp point, the slope between them is 0. I mean, if you graph it, I want to do that. This is for me, not for the packet. If you graph it, you can find the derivative from a graph. And I wonder if the derivative from a graph would be different. It's under calculations, number 6. This is how you have to do it on a TI-83. But if I do the calculations and find it at 1, oh, same thing. It still says the slope is 0, even though it doesn't have one. I was just kind of curious if it would calculate it differently. Okay, what was the next one? Cube root of x? And then this one was supposed to be undefined because it was vertical. I'm not actually sure what the answer is going to be. It's probably going to be scientific notation or something. Cube root of x is under math. And then it is number 4 or number 5. Oh, 100, okay. So apparently the points were close enough that it wasn't at the straight line part, it was one right here and one right here. Apparently they were 100. And then the third one was a vertical asymptote. And this one, it should botch it and not do well at all, but we'll see. was it x minus two?
X plus two.
X plus two.
X plus two squared.
X plus two squared, oh. Well, x plus two, it screwed that one up too. Zero?
Yeah.
That's actually kind of, oh, actually, that does make sense to me. Because one over x plus two, the two pieces are opposite sides. And so if it was reading them really close to each other, it would have one high, one low. But x plus two squared, they are both pointing up, so they would be equal to each other. Do you guys know how to insert? Okay, so if you insert, then you don't have to erase everything. Not that that one was hard to erase. Did anybody type it in without the fraction bar? I was just kind of curious if it came out the same or not.
It's same.
Same, okay. Sometimes just the way the calculator comes up with answers, it sometimes reads things differently depending on how you type it in. But the purpose of putting these three up here obviously was just to show you that the calculator, it's great at calculating things, but it also has a set process on how it does it, so you can't always like fully 100% trust it. It's just kind of there to assist you. Okay, almost done. Wait, wasn't there something on the bottom? Yeah. I was gonna say, I thought, remember the calculator not being the end part of it. Okay, this, I put this up when I taught yesterday's portion in 6th hour, and I thought maybe this would help. I don't know if it does or not, but once you start understanding what continuous means and what differentiable means, this makes more sense. I mean, like, if you're just trying to memorize it, it's not gonna help at all. It's just info. We talked about how just being continuous doesn't mean it's always gonna have slope. Could have a sharp point. But we also did talk about how differentiable, the fact that you can find a slope because it has a left and a right, guarantees it's gonna be continuous. We didn't talk about this, but I thought I would make sure to add it on there. If something is not continuous, that guarantees it's not gonna have a slope. It's not differentiable if it's not continuous. So we didn't mention this one, but this was helpful on that piece function one we did at the end of the hour.
So on a test, if it's like, you find out it's not continuous, do you have to keep going to find like the slopes and stuff?
No,
Okay.
no, definitely not. No, that's good. That would be, you could just immediately use that reasoning. Say you don't need to find it because it's not gonna be differentiable. And this question is sort of based on that info. So, like, this will be something similar to an AP test where it'll say, you're told that f of x is a differentiable function at 3, and that's all you know. And then we're supposed to be able to infer and figure out things because we know it's differentiable. So, A, why do we automatically know that f of 3 has an answer? If it's differentiable, you've got a slope to the left, slope to the right. We also know that it's guaranteed to be continuous. And if it's continuous, we're guaranteed the limit to the left is equal to f of 3 is equal to the limit on the right. Well, if it's continuous, that guarantees that f of 3 has an answer. That's all we were looking for. And then B is actually pretty much the exact same thing. And that's because if it's continuous, you're guaranteed these two are equal, because that's the definition of continuity. These two, I actually don't even really know what it's trying to ask you. Because it says, explain why each statement below is true, but this statement doesn't tell us anything. This statement is just like how you would start slope. Well, it doesn't tell us anything. I'm assuming what the question is supposed to be is that there will be an answer to this, like there will be a slope answer. That's what I'm guessing. But otherwise, these bottom two are pretty much the same question. They're both finding the slope at 3, written in different ways. Okay, I'm done. I mainly wanted to talk about A and B, because that's where we would use that information. Okay, you should be able to do anything out of section 4. I realized this morning that I haven't updated your calendar here, but just to give you guys kind of a timeline in your head, the test will be next week at some point. Because we only go up to 2.7, I believe it is. I think this unit only goes up to 7. If I remember right, 5 is the power rule, but I could be wrong. Once we start learning the quick way to derivatives, it's super fast. So, like differentiability is a slow topic, even though you don't really do much. Some of our other sections aren't gonna go slow. So, mentally peg the test for next week in your mind. No, I don't know what time next week, I'm just kind of giving you a general guideline. And if it isn't next week, well, that's fine, we'll definitely, as we get closer, we'll definitely talk about when it would be. Is that too soon?
Oh, no, that was what I was talking about.
Oh, okay.